Hello everyone, don't forget to subscribe to this channel. Dimension. You are all welcome to today's class. Our topic today is dimension. To find the dimension of any physical quantity in physics, the first letter of the three basic fundamental quantities are used, which are mass, capital letter M for mass, length, capital letter L for length, time, capital letter T for time. The physical quantity which we want to find the dimension is usually written in a square bracket. Then this physical quantity is broken down to its simplest form using its formula and then simplify after substituting the first letter of the fundamental quantities. If you have a proper understanding of derived units, this will just be a walkover. To find the dimension of a physical quantity, we will write out the formula of the physical quantity in a square bracket, then put in the dimension and simplify. Let's take a few examples. 1. Volume. Volume is written in a square bracket is equal to length times breadth times height. Length in square bracket, breadth in square bracket, height in square bracket. Breadth is also length and height is also length. So it is written length times length times length, which is equal to L cube. Speed. Speed in square bracket is equal to distance over time. Both distance and time are written in square brackets. By the time we substitute in the dimension, we don't need to write them in square brackets anymore. And that will give us L over T. And that will give us L T raised to power minus 1. Acceleration. Acceleration is equal to displacement over time times time. By now, we should be familiar with this formula because displacement over time is velocity and velocity over time is what will give us acceleration. So acceleration is equal to displacement over time times time, and that will give us length. Displacement is length, L over T raised to power 2. So by the time T raised to power 2 moves up, it will become T raised to power minus 2. And our dimension for acceleration will be L T raised to power minus 2. Let's take force. Force is equal to mass times acceleration. Mass is capital letter M. Acceleration is LT raised to power minus 2. We just put them together and we'll have for force M LT raised to power minus 2. Then we have power. Power is equal to work done over time. And work done is force times distance. And force is mass times acceleration. By the time we put all this together, work done will be mass times acceleration times distance over time. Mass, capital letter M for mass, acceleration L T raised to power minus 2, and distance is length, capital letter L, divided by time, capital letter T. Capital letter T will move up and become T raised to power minus 1. So, and we have T raised to power minus 2. So, T raised to power minus 1 and T raised to power minus 2 together will give us T raised to power minus 3. And we have L and another L there. By the time we put them together, we have L square. And power will now give us the dimension of M, L raised to power 2, and T raised to power minus 3. We now take impulse. Impulse is equal to force times time, and force is mass times acceleration. So impulse will now give us mass times acceleration times time. Mass is capital letter M, acceleration is L T raised to power minus 2, and time is capital letter T. So T raised to power minus 2 multiplied by T raised to power 1 will give us T raised to power minus 1. And that will give us MLT raised to power minus 1. Now we want to take some questions from WAEC starting from 2025. Question 1. A missile is launched vertically upward with an initial velocity u at an angle theta to the horizontal distance. R, often referred to as the range, represented by the expression r is equal to u squared sine 2 theta over g. 2025 WAEC question. We are now to determine the dimension of r. R is equal to u squared sine 2 theta over g. You are given the formula. So r is written in square bracket, u squared in square bracket, g in square bracket. Sine 2 theta is a constant. Constants do not have dimension, so they will just go away. So by the time we substitute for u is an initial velocity, and velocity is L t raised to power minus 1. So squaring both of them, we have L squared t raised to power minus 2 divided by g. G is acceleration, which is L t raised to power minus 2. So t raised to power minus 2 will take care of t raised to power minus 2. They will cancel out, and we will be left with L squared over L. 1 L we cancel 1 L, and our final answer is just L. Now let's take example 2. Derive the dimension of surface tension. 2024 WAEC question. So the dimension of surface tension, we write surface tension is equal to force over length. Surface tension is written in square brackets. Then force is mass times acceleration. Mass is written in square bracket, acceleration in square bracket, divided by length in square bracket. Then we'll put in the dimension for mass, capital letter M, dimension for acceleration Lt raised to power minus 2, divided by the dimension for length L. So L, we cancel L out, and what we have left is Mt raised to power minus 2. The question on dimension for 2023 and 2022 is on dimensional analysis. We will take the question after we have treated dimensional analysis. The next question on dimension is state the dimension of impulse, acceleration, and work. And we have done all this. We are just to state the dimension. That is 2016 WAEC question. I hope you enjoyed the lesson. If you have any question, drop them at the comment section below, and I will respond to them as soon as possible. Do not forget to subscribe. Bye.